Okay, do we have a lot of questions? Of course we have a lot of questions. This is period 6. See, who wrote 911?
Not I say that.
Okay, what are we on? Function 2?
Yes.
And then function 3 is tonight. Function, come on! Okay, tonight's lecture should be pretty darn easy. Today's lecture. Okay, here we go. Okay, so we have questions. Okay, I don't even understand that. 2 examples from number 2. What does that mean? Okay, let's just take care of 1A. Oh gosh. It's so disappointing, it's funny. Didn't I show you how to do this yesterday? Oh, yeah, but it was different numbers. Okay, so 2, 2. Oh, that's the same point we had yesterday. Yeah, because you changed the other points though. Confusing me. And then 4, 0. Doesn't it look vaguely familiar from yesterday? Okay, so did you guys label key points like this? Okay, 1A, write this as a piecewise function. So f of x is equal to, and then since this is 2 here, x is less than 2, x is greater than or equal to 2. Does it matter which one I put the or equal to on? No, because they both meet at that same point, so it doesn't matter. Okay, this line, what is the slope? What's rise over run? 2 over 4 is 1/2. And then since it has to pass through the point 2, 2, if you plug in 2, you get 1, so plus 1 then, right? Okay, now from here to here, the slope is going to be 2 over 2, which is negative 1. But it's got to pass through the point 2, 2, so if you plug in 2, that's negative 2. What do you have to add to negative 2 to get 2? Negative 2 plus what will give you 2?
4.
4. Boom, there you go. Anyway, if that's confusing, just do point slope form. Okay, well, the slope is negative 1. And which point do you want to use? Which point?
4, 0.
Okay, so y minus 0 equal negative 1 times x minus 4. And then when you solve for y, don't you just get negative x plus 4? I mean, do whatever you have to do, right? Okay, and then h. Y equal f of x. What do you do when you see absolute value? I thought I trained you already. When you see absolute value, A, skip to the next problem. B, write a piecewise function. Those are your only 2 choices. You write a piecewise function. If the inside is positive, you leave it alone. If the inside is negative, you negate it. That should be automatic already. Okay, now simplify this. What is f of x plus f of x over 2?
F of x.
F of x. And then what is f of x minus f of x over 2? 0. So what, Mr. Park, I'm not used to f of x here, I'm only used to x. F of x is like y, right? When the y coordinates are positive, the function just stays the same. So here's the original graph. Okay, let's do this in color. What color do we like? Blue. So when the y coordinates are positive, in other words, when the graph is above the x-axis, you don't touch it. So it just stays there. However, if the y coordinates are negative, in other words, if the graph goes below the x-axis, then you graph y equals 0, which is this. Oka! Katanga! Did you guys get that? Anyway, when you see absolute value, you think piecewise function, not skip to the next problem. And then 2 examples from number 2, I'm not sure what that means, and 911, what the heck does that mean? Who wrote the 911? Yugawa? Okay, I'm gonna find out who did this. Because I know your handwriting already. Okay, so it's kind of nice, the handwriting, so that rules out Kobe. And And the way the 9 is, it's kind of a little demented, so you rule out all the females. So it's a male. Asian ancestry. Because the way the thing on the 9, so it rules out Callahan and Morris. That's racist!
I live in Korea. I'm Chinese.
What?
I'm Chinese.
I'm trying to figure out who it is. Just let me concentrate. Lum!
No, my handwriting's not that nice.
You're right.
Yeah. Oh.
Have to be a Korean. So what does that mean? Am I really doing it all or what? I'm not going to do it all. So what are we doing? What is that 2 example? I can just do any 2 I want. Is that what you want? Okay, fine.
For 2A, the last point for the x-coordinate 4, I don't think this
Okay, why don't we just do all of it from the beginning then? Okay, now to do this problem, you know what it's easiest thing to do is to make a chart. Can you guys make a chart?
No.
If you make a chart, to me it's easy. So 0, 1, 2, 3, wait, 1, 2, 3, 4, goes to 4, yeah? Okay, which one is f? It says f of 0 is 2, so f is the one that goes like this. Okay, so what are the y coordinates of f? 2, 2, 2, 1, 0. And what are the y coordinates of g? 1, 2, 3, 3, 2. Did I do that correctly?
Yes.
Yes, I'm the teacher. Now, if you make a chart like this, then isn't it easy to do these things? Like, for example, I'm falling into your web of deception again. I'm just going to end up doing them all, yeah? Y equal f plus g of x, which means, of course, f of x plus g of x, which means you just add the 1, 2, 3, 4. So basically, you just add the 2 y coordinates together. So when x is 0, what is f plus g? 3. What is 2 plus 2? 4. 2 plus 3? 5. 1 plus 3? 4. 0 plus 2? 2. And so just connect the dots.
Daddy, you have 1 on answer sheet.
How dare you? Where are we? Oh yeah, you're right. Make the correction. Oh, that means you gotta do the whole thing again. Look, I hand wrote everything too. That's funny.
No.
You take pleasure in everything. Okay. Now, did you notice that some of them, Mr. Park, can I just plot the points and then just connect them with straight lines? Yeah, you can get them wrong. How come sometimes it's a straight line, but sometimes it's a curve? Did anybody even wonder that? No? Or any wonder?
I wondered.
Saka? I will wonder when I do the homework. I can't see that far away. I know the trick. Anyway, so which one you want to do then? How about F? You want to do F? Okay. Where's that? Like, you know what? I gotta draw the original graph to explain it too. So 1, 2, 3, 4. 1, 2, 3, 4. So let's see. F goes like this. Honga bonga, ahunga hunga. And then G goes whoop, 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 whoop. Okay. This is F, this is G. Okay, we're doing F. Graph y equal f squared of x. What does that mean? That means f of x squared. Basically, you just square all the y coordinates on the graph. That's what you do. So 1, 2, 3, 4. Woo! Okay, so here we go. Here's f. Just square each of these y coordinates. So 4, 4, 4, 1, 0. Come on, that's just easy. So 4, 4, 4, 1, 0. Okay, now the question is, can I just connect everything with straight lines? Yeah, you can, but then you're gonna get points marked off. Now, right here, why can I do this? Because look, what is f? From 0 to 2, isn't f a constant? it's 2, right? What happens when you square a constant? It's still a constant, right? So straight line. Okay, but over here, what kind of function is this? Rhymes with linear. It's a linear function. What happens when you square a linear function? You get quadratic. And that's why it's a curve. It's a parabola, that's why. You guys get it? Now do you wonder? No wonder, no more. We know. Some of you go, what are you talking about? Well, what's the exact equation of this? Quick, just do it fast.
-2x plus 4.
No, 4 minus x, isn't it? The slope is -1, the y-intercept would be 4, right, if it goes up there. What happens when you square this?
16.
You will get y equals 16 minus 8x plus x squared. Hey, that's a parabola. That's why it's not a straight line. That's why you have to put, that's why I gave you this problem, because anybody can just plot points and connect it with straight lines, but sometimes you don't connect it with straight lines. And that's the purpose of this thing here. When to connect with straight lines and when to not. So does anybody want to ask something else, like, to clear it up? Like, what about the ones with the vertical asymptotes?
How come some have vertical asymptotes?
Okay, thank you. Okay, like which one?
E and G.
Which one?
E and G.
E and G, so pick one of them. Which one do you want to do? E looks more interesting. E looks more interesting. E is G over f of x. So what you have to do is take the y coordinates of G. You know what we should have done? We should have just done different color. 1, 2, 3, 4. Too late. 1, 2, 3, 4. Don't even put that. I will. Okay, what? If you take the y coordinates of G and divide it by f, what do you get? 1 divided by 2.
1/2.
It's a half. 2 divided by 2. 3 divided by 2. 3 divided by 1. 2 divided by 0 is undefined. Okay, now, between 0 and 1, straight line or curve? How do you know? Well, I'll tell you right here. This is a straight line right here. In fact, didn't it say straight and curve? How do I know this is straight over here? Okay, between 0 and 2, look at between 0 and 2. What kind of function is G? Linear. It's a line. In fact, isn't that exact equation going to be x plus 1 in fact? And then, what about f? What is f?
Constant.
It's a constant. In fact, the exact equation is 2. So if you divide a linear function by a constant, it's still linear. So that's why you get a straight line. Okay, but between 3, okay, where's G? Between 3 and 4, what is G?
Constant.
It's constant. Well, that's also linear, but the exact equation is actually 3, right? And then you divide it by f, which is 4 minus x. Hey, that's a rational function. So it should be curved. So that's why we're here. Curve. Anyway, all you have to know is it's either linear or not linear. That's all you gotta know. Straight line or curve. You don't have to know that. And then, what about between 3 and 4? What is G? What is G?
Linear.
It's linear. Divide that by f.
Linear.
What do you get? Rational. That's why it's going to be curved. Now the question is, Mr. Park, why is there a vertical asymptote right there?
Undefined.
Yeah, no. That doesn't. Just because it's undefined, that doesn't mean there's a vertical asymptote. Because you could have a removable discontinuity.
Can't be 4.
Huh? Or for you, Mr. Rubash students, red flag. And then Mr. Takeyasu students, hold. Yeah, but just because it's undefined, there could be a lot of things that happen in the graph. Vertical asymptote is just one thing that can happen in the graph. Well, how do I know this one is a vertical asymptote? Somebody come up with something intelligent.
There's nothing after it. 'Cause the
No,
graph-
something intelligent. What do you mean there's nothing after it?
there's
No,
nothing-
that is nothing. Okay, Park, Team Korea.
3 over 4 minus x can have 4 as x.
Yeah, that's because we already know that. It's undefined in 4. But how do you know there's a vertical asymptote?
Because it can't be 4.
No, but you could have there's so many things can happen. Oh. Just because it's undefined, that doesn't automatically mean there's a vertical asymptote. Again, there could be a red flag. I don't know why you call it a red flag. Why is this called a red flag, by the way?
It's like water.
Yeah, so we'll watch out for it.
Yeah,
Watch out.
Watch out because it's not.
Okay, let me just show you then. Okay, now, what if you were to plot more points like in between? Like what about at 3.5? What's the y coordinate of G? Right here. No. Right here is 3. This is 2. Okay, 2.5. And what's the y coordinate of F?
1.5. Oh, half.
No, half. What's 2.5 divided by a half?
5.
Wow, whoa, it's getting bigger. Oh, and what if you get like really close, like right over here? What if like at 3.9? What's the y coordinate here going to be?
Really big.
2.1. 2.1. What's the y coordinate there?
0.1.
0.1. Ooh, what's 2.1 divided by 0.1?
210.
No,
14.
21. 21. Oh, that's getting bigger. And then what if you get even closer? Like what if you like 3.99? Then the y coordinate over there is going to be 2.01. But then you got to divide that by 0.01.
210.
No, 201. Hey, it's getting really big. That's because when you keep on dividing a number by a number close to 0, it gets really big, and that's why you get a vertical asymptote. That's why. You guys understand? Because you're dividing by a number that's very close to 0, so it gets really big. And that's why in problem G as well, see how right over here, the y coordinates are getting close to 0, so when you divide by 0, the y coordinates is big. Vertical asymptotic. Okay, does that take care of it, or you need more explanation on this? Oh, we can finish early today then. Yeah! There's only 2 more lectures, you know. So we have, today we're going to learn something, tomorrow we've got all word problems. That's the interesting one. So yes, you're going to need your graphing calculator on the quiz and the test. I don't know if you're going to get there, on the test for sure. Okay, so today, see look, you got to draw a face. That's homework. Using that semicircle from yesterday, you got to draw. Okay, what do we have to learn today? We got to learn how to find inverses. Come on! And then composite function. Okay, what do you guys know about inverses? Let me give you a really simple problem and see if you can handle it. F of x is equal to 2x plus 1. Do I like that?
Yeah.
Yeah, I do. Okay. What if I ask you to find f inverse? Now, this symbol here means the inverse of f. This does not mean f of x under 1. That does not mean it. So when you use this with function notation, it means inverse now. So if you do this, that's a fatal error. Now, how did we learn how to find inverse in algebra 1 and 2? You switch the x's and y's. So this is like y. So you switch the x's and y's, so you get x equals 2y plus 1. And then you solve for y. So you get 2y equals x minus 1, y equals x minus 1 over 2. That is the inverse. So a lot of tonight's homework, you have to find the inverse. Well, we have to learn things about the inverse, so I'm just going to review the things we learned last week. What would happen if you draw this graph? Go. Quick, draw this graph. Too late. 1, 2, 3, 4. 1, 2, 4. Okay. Y-intercept 1, slope 2. So, draw this graph. Y-intercept,
Negative 1/2.
-1/2. Slope,
1/2.
so 1/2. Wait, what did I just say?
No, rise
So-
1, run 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2.
Just keep repeating it. 1/2. There. Right? Quiet, I'm trying to do things. There's the inverse. Woo, there you go. And anytime you graph any, well, it doesn't even have to be a function, the graph of any relation and its inverse is always going to be symmetric about? No. The line y equal x. That's one of the properties of inverses, right? Is this all coming back like a bad dream? And that's not the most important, this is the most important thing here. If you have a function and its inverse, what happens when you plug one into the other?
Like this.
And it doesn't matter which order. Yeah, the answer is X every single time. That's one of the most important things. That's why it's in your book, right? Last year and it's in the notes this year. So on tonight's homework, that's just nonsense on tonight's homework.
Okay.
Okay, anybody can do lines, okay, but let's kick it up a notch. F of x equals 2x plus 3 over 5x plus 7. Find the inverse. How do you do that? Switch the x's and y. So this is like y, right? So x equals 2y plus 3 over 5y plus 7. Okay, but now you gotta solve for y. How the heck do you solve for y? What's the first step? Right to Haas multiply. That's the only way you can get it. What's everyone's gonna do when you go to college? You think the teacher is gonna say that? You rhymes with Haas multiply. That's just truly sad. Put all the y's on one side, put all the x's on the other. Factor out the y. We just did this in Algebra 2b. I gave them this exact same problem and they all could do it. And then you divide. Y equal negative 7x plus 3 all over 5x minus 2. The negatives cancel out, so you get 7x plus 3 over 5x2. But the x's cancel out, so you get 7 plus 3 over 5/2. Oh, but that's 10. 10 over 52, which reduces to 5 over 26. I guess that's all you can do, that's your answer. So stupid. That is dumb. That's the answer. Negative 7x plus 3 over 5x minus 2. I think Mr. Rubash's class, didn't you guys like figure out a pattern from last year? Because I know he likes to do that. Like whenever you see like an expression like this, then look at the inverse. See how the numbers are the same but in different places with different signs? No, nobody remembers anything. Whatever. Anyway, how do you verify that this is actually the inverse? Well, if you were to take this and plug it, no. Okay, here, come on. This is next chapter we're going to draw the graph. If you take this and plug it into this one, or take this one and plug it into this one, you will get x. And most of your, like the book last year, they made you do that, but I'm not going to make you do that because we already know that already. You know what I'm talking about? Okay, now let's do a higher level thinking problem and then we're done. F of x is equal to, I don't want to do the same as tonight's homework. Should I make it a little different? No. You guys even know what I'm talking about, yeah? Just give, you know what? Why don't I just do the same problem? Yeah, I'm just going to do it. G of x is equal to x squared, right? Isn't this one of the problems of tonight's homework? Yeah, what the heck? You're going to make me do it tomorrow anyway, right? Okay, here, graph. Y equal f of g of x, part A. And then part B, graph y of g of f of x. Well, first of all, what is f of g of x? What happens if I take this function and plug it into that function? You get the square root of x squared, which is? Very good, absolute value of x. You remembered that. So now you just graph it. So, whoa, easy. As long as you remembered absolute value. Yeah? Now what would happen if you take f and plug it into g? Then you're going to get the square root of x squared, which is x. Oh, I can do that. Y equal x, it's like this, Mr. Park, so easy. Minus 3. Yeah.
You can't have negatives.
Why not?
Because you can't have a negative square root.
You had it and then you lost
Yeah,
it.
you can't have a negative under the square root.
No, it's the domain of the inner function. That's why. What's the inner function here?
F of x.
Wait, let me point at it. F of x, right here. What's the domain of this? How do you find the domain of any radical thing? The inside got to be greater than or equal to 0. That's why. So it's not the whole graph. It's only the part of the graph that's greater than or equal to 0. So it starts here. Ow. You guys understand? Oh, so Didn't you guys do a lot of work with the domain and range of composite functions last year? Mr. Rubash said you did. You gotta look at the domain of the inner function as well as the domain of the whole composite function. Does that sound familiar? Does Mr. Rubash have a word for that? Something, wait. They told me something about you take the thing.
In the box.
Yeah.
Put it in the box.
Yeah.
And then the next box.
Yeah, what does he call that?
I don't know.
How did something
Bucket
factor?
method?
I don't know.
Bucket, right?
Oh, yeah.
You put it in a contraption.
Put it into a contraption,
And you just keep going.
Bucket method.
Bucket, yeah.
the bucket.
It changes.
Okay. Okay, well, I just did one of your homework problems for it. Shall I do more?
Yeah.
Well, let me look. Look, tonight is so okay, I'll do one then. No, I'm not gonna do one. I'm gonna do one example like it. No, you know what? I'm not. Actually, we're done. You guys need to. I just spoon feed you guys. You guys like that? Yeah, it's working right now. When you go to college, do you think your professor's gonna spoon feed you? You go to BC Calculus, I tell you right now, Mrs. Goldtham doesn't spoon feed. You gotta be able to chew on meat. I don't know if I'm helping you by spoon feeding you, Practice tests. There's no practice tests in BC. If you go to AB, yeah, we get plenty of practice tests because they're AB, that's why. But in BC, there's no practice test. You just learn the thing and take a test. Okay, the bell rings in. What is today? Oh, 9 minutes then. You got 9 minutes.